So next we're going to visit about what is meant by this term function notation. Instead of always having to write our equations with just x's and y's, it's going to be cumbersome once we add more and more and more equations to the mix. Okay? So we need to have a different type of notation to describe different equations. All right, so it says when you have a function, when that is defined by an equation, we're going to often use function notation. For example, this y equals x minus 2 may be written in function notation as f of x equals x minus 2. Okay, in this notation, the f is the name of the function, x is the input value, and then the quantity f of x is basically the y value that would correspond to the x value. So in a nutshell, what we might want to do is instead of having x, y ordered pairs, we might want to calculate x and then function values at x ordered pairs. Okay? So really in a nutshell, f of x is just a fancy way to write y when you have a function. And there are advantages to that, as we'll see on this next example. One thing I do want you to definitely wrap your brain around is remember f of x means y. It does not mean f multiplied by x. We are so programmed that anytime we see a parenthesis in algebra, that means multiply. Well, not always. That parenthesis in the f notation, when you write f of x, that does not mean f multiplied by x or f times x. All right, so here's an example of how you evaluate your function at different values. And this is instead of having to fill out a chart, okay, you could write this notation. First of all, here's your rule. Okay, f of x equals x minus 2. So when x is equal to 4, okay, replace the x with 4 and you have 4 minus 2, which is 2. So to say f evaluated at 4 equals 2, that's another way to express the ordered pair that satisfies that relationship as 4, 2. Let's look at another situation here. When x is equal to 1, you want to find what is the function value at 1. When x is 1, what is y? Well, you put the 1 in for the x, okay? Then you're going to go 1 minus 2, and that comes out to be negative 1. So we would say f evaluated at 1 is equal to negative 1. And really that gives you an x, y ordered pair, 1, negative 1. So using function notation is a different way to calculate some ordered pairs. It's just a different way of looking at it. But again, we have input values of x and output values of f of x or y. Now, we're not just restricted to name a function using an f. You might see also g of x is equal to whatever it is. Or you might see h of x is equal to whatever that's defined to be. Sometimes we'll see, I think on the next example, we get to see an m of x, okay? So that name can change. So with that idea, we can then evaluate several different functions, okay? On example 5, we're given 3 different functions. And let me kind of color code these. All right? F of x is equal to x squared plus 3x. Okay? Totally different function is g of x. G of x's rule says to take 1 over x, or find the reciprocal. All right? H of x is equal to 5. That's the rule, okay? And then over here, k of x is equal to the square root of x plus 1. So what we're going to have now And I know that these numbers are all kinds of messed up, but we're just really wanting to, for example, on this b, whatever that is, okay, we're wanting to go to our f function and evaluate it at -1. So y'all, f evaluated at -1 means go to your f function and where you had an x, replace that with a -1. So f evaluated at -1 is -1 squared plus 3 times -1. And we need to figure out what that is. -1 squared is +1, but +3 times -1 is -3. So f evaluated at -1 gives us -2. Okay? And I would like to go ahead and write that. I'm going to kind of cheat my little area right here. I'd like to go ahead and say f evaluated at -1 is -2. We just found an XY ordered pair that would satisfy that equation. Therefore, it would go on the graph if we were going to be graphing f of x. All right, let's do our f function evaluated at 0. Go up here to your f function and square the x value, add to that 3 times the x value. So 0 plus 0 is 0. So my f function evaluated at 0 gives me, whoa, I didn't mean to draw that parenthesis right there. That's unnecessary. That's equal to 0. Okay? Now, with f notation, we are also allowed to evaluate our functions at not just boring old numbers, at also other values or quantities. So like on number 48, our f function evaluated at a means go to your f function and where you had an x, replace that with an a. So our f function evaluated at a would be equal to the a squared plus 3 times the a. And that's your answer. Okay? That is what we would get if we would replace x with a. All right, let's move on, and now let's work the next set of examples working with our g function, d, e, and 56. Okay? So g evaluated at, see how I'm saying that? I am not saying g times 1/2. No. I'm saying my g function evaluated at 1/2. That means go to your g function and where you had an x, replace that with what you're supposed to replace it with. 1 over 1/2 is 1/2's reciprocal, which is 2. Okay? G evaluated at 2 means go to your g function, replace your x with 2. So g evaluated at 2 is 1/2. G evaluated at x plus h. Now here you don't do the distributive property because again, remember these parentheses do not mean multiply. We read this as g evaluated at x plus h. That means we're going to go to our g function, and where we had an x, we're going to be replacing that with x plus h. So g evaluated at x plus h is just 1 over x plus h. Okay? Moving on to this purple h function. H of x equals 5. Well, on this one, the rule is your h function is always equal to 5. This is like saying y is equal to 5 no matter what your x value is. So h evaluated at -2, we don't have anything to put in for x anywhere, right? H evaluated at -2 is 5. H evaluated at -1 is 5. It's not going to change because we don't have a variable for x. Okay? H evaluated at purple elephant would be 5. Okay? I don't know why you want to do that, but you could. Okay? So over here on our k function, k is equal to the square root of x plus 1. Okay? So when we're doing k evaluated at -2, we're going to be evaluating the square root of -2 plus 1. I replace the x with what I was supposed to replace it with, -2. So on this one, we get square root of -1. Ooh, which you remember what that is? That is I. Now, what we're supposed to be doing is figuring some ordered pairs here. And so if you were going to go graph this k of x equals square root of x plus 1, and you would say, okay, well, I'm going to go plot the point -2i. I don't know where in the world you would put that in your plane, in your rectangular coordinate plane. Okay? So what we say is when we get a non-real number, we say that k evaluated at -2 is undefined. And it's undefined for our real numbers because we got an imaginary, because the square root of the negative. Okay? Let's see what happens here when x is -1. I'm going to do k evaluated at -1. That means to calculate the square root of -1 plus 1. That'll give us square root of 0. And I'm okay with square root of 0. That's just equal to 0. There's our answer. So -1, 0 would be a point on our graph. Okay? K evaluated at 0 is the square root of, replace the x with a 0. So k evaluated at 0 is just square root of 1, which is 1. Okay, so k evaluated at 0 equals 1. There is another xy ordered pair. If I were going to go graph this function, I would be putting a dot there as well.